Okay, so today I'll be talking about Albert Einstein's photoelectric effect. The photoelectric effect refers to the emission of ejection or electrons from the surface of generally a metal in response to an incident light. Energy contained with the incident light is absorbed by electrons with the metal, giving the electrons sufficient energy to be knocked out of, that is, emitted from the surface of the metal. Using the classical Maxwell wave theory of light, the more intense the incident light, the greater the energy with which the electrons should be ejected from the metal. That is, the average energy carried by an ejected photoelectric electron should increase with the intensity of the incident light. Einstein successfully resolved this paradox by proposing that the incident light consisted of individual quanta, called photons, that interacted with the electrons in the metal like discrete particles rather than as continuous waves. For a given frequency or color of the incident radiation, each photon carried the energy E equals hf, where h is Planck's constant and f is the frequency. Increasing the intensity of the light corresponded in Einstein's model to increasing the number of incident photons per unit time, while the energy of each photon remained the same. Clearly, in Einstein's model, increasing the intensity of the incident radiation would cause greater numbers of electrons to be ejected, but each electron would carry the same average energy because each incident photon carried the same energy. Light and other electromagnetic radiation such as radio waves are obviously waves, or so everyone thought. Maxwell and Lorentz had firmly established the wave nature of electromagnetic radiation in electromagnetic theory. Numerous experiments in the interference, diffraction, and scattering of light had confirmed it. We can well appreciate the shock and disbelief when Einstein argued in 1905 that under certain circumstances light behaves not as continuous waves but as discontinuous individual particles. These particles are light quanta and are carried a quantum or fixed amount of energy, much as automobiles produced by an assembly plant arrive only as individual identical cars, never as fractions of a car. The total energy of the light beam, or the total output of an assembly plant, is the sum total of the individual energies of these discrete light quanta, what are called today photons. Theories of matter and electromagnetic radiation in which the total energy is treated as quantized are known as quantum theories. Although Einstein was not the first to break the energy of light into packets, he was the first to take this seriously and to realize the full implications of doing so. He received a Nobel Prize for the photoelectric effect in 1921.